Hello everyone, I'm Dr. Mehraei, and today we are going to talk about regression. So if you remember, we talked about correlation coefficient before and why we are interested to investigate the relation between x and y as two random variables. So there were different scenarios like x and y, they had no relation. It was totally random. Like here we have weak relation between x and y. Here we have high relation between them. And here this is perfect. It rarely happens that we have such a linear relation between x and y. Usually we should have residuals as we will talk about it. So in case if we have such a slope, this is positive. If this is the case, this is negative. Both of them, we could say they are highly correlated. Only the slopes are different. Here also we have a high correlation. This is a strong correlation between them. And this one is nonlinear instead of having such a linear trend. And for this case, you can see from this point to this point, we can see a linear relation, but starting from this point, it gets random. But we are interested to see if we can come up with a formula to model this data as the trend of the data. And this is useful because using that model, you can find the missing data, or by finding, I mean estimating them because we don't know exactly what's going on there as missing data. So we want to estimate them or even predict the future. Whenever you predict the future, it's not certain, it's not 100%, but at some certain confidence level, still you can predict the future. So you see, modeling your data is very important. To do that, we have such a formula. And whenever it comes to regression, we divide it into linear and nonlinear case, like the previous slide as we showed you. So it can cover all of them, or even these x's can have power like x power 2, x2 power 3 to make it nonlinear, or even these multiplications beta 1 to beta n could be defined as matrices, and even the constant here, we will see that how it can affect your final answer for y. But in our course, we want to talk about the simple linear case. It means that beta 2 to beta n, we consider them to be 0. We will have the simple linear case of y is equal to beta 0 plus beta 1 multiply x1. So we have our y-intercept and slope of the line, which are important for us to estimate. And we have x instead of x1 because we have only one x, you don't need to any index there. All right, so assume that you have your data, x and y, the number of them are exactly the same because we have pairs of them, okay? So you can now draw the scatter diagram, which you also did in your second assignment, well, for most of your projects. Okay, so whenever you have such a data, then you can, of course, find the coefficient, uh, correlation coefficient, and also uh, investigate whether they are related or not. But if you want to find the formula to model it, in case if you know only the linear uh, version of regression, then it could be something like this. So this line is what you came up with. This is the formula that you gave to us. And we will discuss how we can come up with such a line. We can discuss about those beta 0 and beta 1 so that we draw this line. And of course, as we said, it's almost impossible to have such a perfect line to exactly represent your data. You see, these are your actual data, and these are y1, y2, y3. These are your actual data, and this is the line that you plot. So of course, there are some errors between them. So the y's corresponding to the same x for y1, we call it y1 hat, because this is your estimation. And the difference between them, call them residual. So residuals are the differences between your actual value with the estimated one. So these are your errors, and we are interested to minimize them. So the line that we want to draw, whether they are linear, non-linear, they should be perfect. I mean by perfect, just minimize your error. And that's what we are looking for, because it never happens. We could say that we can have a perfect line for it. Okay, so as we said, this is your error, this is your residual, as we call it now. And we are not interested whether this value will be negative or positive. That's why we power it by 2, the same way we did it for variance the first time, so that we get rid of that negative signs. So this is the one that we are trying to minimize now. Okay, so this is our goal. And of course, as before, as I said, I eliminate the proofs for you, because as engineers, you don't care about those proofs. It's reserved for pure mathematicians and pure statisticians. So if you're interested, of course, you can go through it in the book, that how we get partial derivative from those equations to come up with the answers for beta 1 and beta 0. But I'm going to show you the method of least squares, all of them in the same slide, that how we can calculate them, because as engineers, you are interested in applications, of course. All right, so first thing first, we can compute our mean of x and mean of y. So they can be easily done. You already know the formula. And pay attention to the notations now. This is very important. Now, s double x instead of just 1x. If it was 1x, it meant the standard deviation of your sample, right? But when we have 2x's, this one represents s power 2x. This is exactly the same. Okay? So you see the formula is the formula for the variance of your sample. Now for regression, don't forget to show the notation like s double x. These are the things that we pay attention in your exam as well when you writing your answers in terms of regression. Okay, so s double x, it means that s power 2x. If you had only 1x here, it was the same as a standard deviation of the sample. And for the population, as we talked about it, it's better to consider it with sigma. So these things that I'm mentioning, that about the notations, these are the ones that exactly we expect you in the final exam, because in different books, they may use different notations, like capital S for population, but lowercase for sample. But in our class, and the way that you should write in the exam, we should follow exactly sigma and S. And for the regression, we should be careful that what we mean by double X here. For this case, when we have X and Y together, it really looks like covariance, right? So instead of writing here again another X, so that we will have power 2 of the differences, here we put Y, so we will have covariance. So you can write it like this one. And for estimating beta 1 and beta 0 by using that proof that I told you briefly, when you want to minimize your residuals, you can come up with such a formula. So this is the formula that you should know. In order to predict beta 1, we can show it by beta 1 hat or B1. And here for beta 0, you can use beta 0 hat, and this one is equal to beta 0. You can show an estimation like that as well. All right, so to calculate this one, you just write covariance here and divide it by the variance of the sample X. And for beta 0, it's pretty easy as soon as you calculate B1 or beta 1 hat. Because based on the formula that you have, it's a simple case of linear regression, and it's very easy after that to calculate this one. All right, and this one is the correlation coefficient that we talked about before. We showed it by row, and here we wrote covariance, and here we wrote the square root of variance x multiply variance y. And when you apply a square root, so it means that you can write the standard deviations right away. So for regression, and when we talk about correlation coefficient, please write this formula also in the exam, not one we told you about rho. I know they are exactly the same, but anyway, since we are talking about regression, let's stick to the notations which belong to regression. I know we still have plenty of time to your final exam, but please go through all the videos, all the materials we provided for you, so that you prepare from now for your final exam. This is a homework exam, so it's going to be pretty hard, comparing even to your midterm exam, which was also a homework exam, but this time we will cover more material, and also uh, we may personalize it. That's why it's very important for you to practice from now. I hope this session was useful for you. See you guys.